Today's problem is farthest, smaller, right, difficulty medium. You're given an array for each element at index I using zero-based indexing. Find the farthest index j to the right, i.e. j is greater than I, such that array at j is less than array at I. If no such index exists for a given position, return -1 for that index. And then return the resulting array of answers. Okay, should we look at the examples first, or the, yeah, let's look at the examples. All right, so example 1 here. The array is 2, 5, 1, 3, 2. So we'll start with 2. The farthest index to the right with a number smaller than 2 is right here, index 2, which is a 1. So we'll put index 2 here in the first position. Now the next one, 5, everything is smaller than 5. So the farthest index to the right with an element less than 5 is 4. So we'll put the 4 in there. The 1, nothing is smaller than 1. So we're going to have to put a -1 in for that. 3. Again, index 4 is, the element in index 4 is 2. That's smaller than 3. So we'll put a 4. And the 2, there is nothing to the right of that. So that gets a -1. All right, well, let's look at this one, example 2. This one's a little simpler because the smallest number is the furthest number to the right. It's at index 4. So every number is bigger than 1. And so the farthest element to the right that's smaller than what am I trying to say? For every number, the furthest element to the right that is smaller than the given number is going to be this 1 at index 4. So they all get 4s, 4, 4, 4, 4, except the last number, which has nothing to the right, so it gets -1. All right, constraints. Array size will be between 1 and 10 to the 6th, 1 million. Elements in the array will be between 1 and 10 to the 6th, also a million. If you were doing this, coding it, you would want to test the edge case of one element to make sure that it works. We have automated testing at our disposal here, so time complexity, n log n. Okay, now that sounds like a sort, but we're really not going to sort anything. We are going to do, as it says under the topic tags, binary search. We're going to do a binary search for every element. So there are n elements. Binary search is log n, so we'll get n log n. Auxiliary space, O of n. So that suggests that we want another array, which we do. The array that's going to help us here, let me get something to write with. Actually, let's take a look at this. How much of this can we see at one time? All right. No, that should be fine. Here, let's do this. Show the toolbar, and we'll go here. We're gonna do example 1. What we want is a suffix array. So we want an array so that every element contains the smallest number that exists at that index or beyond that index. So the way to construct that is to start on the right with this 2 here and say, all right, so we're going to have a 2. And then as we're moving to the left, the number that we want is either the number at that index, which in this case is 3, or the element to the right, whichever one is smaller. And since 2 is smaller than 3, we take the 2. All right, we go to the next number, which is 1. That's smaller than 2, so we take the 1. We go to the next number, 5. That's not smaller than 1, so we keep the 1. The next number is 2. That is not smaller than 1, so we keep the 1. All right, so that is our suffix array. All right, now what are we doing over here? Let me try to make this a little bit more visible. First of all, I'm going to move that. I'm going to try to squeeze this over. I'm going to move this over a little bit. All right. N is the length of the array. Array list. All right, so we have a new array. We're going to put the integers in an array list. Okay. Called ARR list. We're going to create an array list for the answer. The answer is intended to be an array list of integers. So we're going to create an array list for the answer. We're going to initialize that to a length of n, and we're going to put -1s in there. We don't really have to do that. We're going to put -1s in there anyway, but that is our answer. Now we're going to create the suffix list. Okay. So we take the array list, and we're going to take the array list, put it in the suffix list. We are going to set the rightmost element of the suffix, the suffix list, to the last element, and then we are going to move to the left, and at each position we're going to set the min of whatever is in the array list or the element to the right, which is what we did here, and we got 1 1 2 2 2. All right, good. So we've got our suffix list, we've got our answer list. We've got our array list. That's all we need. All right. So let's trace through this. I'm going to go back to this. I is 0. Low is I plus 1, which is 1. High is n minus 1. N is 5. So high is 4. Res is -1. Low is greater than high, yes. So what is mid? Mid is low plus high divided by 2. So that's 5 divided by 2. It's 2. Okay? Suffix array, get, mid. So that would be here. That's a 1. Is 1 less than... I'm sorry, is that right? Yeah. Is 1 less than the array list at I? Well, I is 0, and the array list at I is 2. So 1 is less than 2. So res equals mid. That's 2. Okay? Now, sometimes when you're doing binary searches, you don't want to stop when you find what you're looking for, because you're looking for a max or a min or the farthest something. And so the fact that you found something doesn't mean that there can't be something less or greater or further. Okay, so in this case, we found a number to the left of array at 0, but we don't know if it's the furthest one to the left. So we're going to keep looking. Res is mid, low equals mid plus 1. Mid is 2, low now equals 3. Right? So we'll go around again. So low less than high, yes. Mid, low plus high divided by 2. 3 plus 4, 7 divided by 2 is 3. Suffix get mid, that's a 2. Is that less than array list at 0? No, it isn't. So high equals mid minus 1. Mid is 3, so high is now going to equal 2. All right, we'll go around again. Is low greater than or equal to high? No. We are going to set, so we drop out of the while loop and answer. We should set up the answer array here. Answer. The answer array. Answer at 0 is res 2, so that's a 2. Okay. Next time through the loop, I is 1. You know what? I think it would be better if I just erased these. All right, I is 1. Low is I plus 1, that's 2. High is n minus 1, that is 4. Res is negative 1. Is low less than high? Yes. Mid is low plus high, that's 6 divided by 2, so that would be 3. Suffix get mid, that is a 2. Is that less than array at I, which is 1? Array at 1 is 5. So yeah, 2 is less than that. So then what we do is we'll say res is mid. Res is mid, 3. Low is mid plus 1. Low is 4. We're moving it up to see if we can find another index that is higher than the 3. All right, we'll go through again. Is 4 greater than or less than or equal to 4? Yes. Mid is 4 plus 4 divided by 2. It's 4. Is suffix get mid, which is 2, is that less than 5? Yes. So res equals mid. Res equals 4. Low equals mid plus 1. 5. All right, well, that's going to drop us out of the loop because low is now higher than high. Okay, so we will set I index 1 to res, which is 4. Okay, good. Let me erase some of this. I didn't want to erase that. Okay. I don't think I can undo that, but that's going to be 2. Let's just remember that that's 2. All right. I is going to go to 2. Low equals I plus 1. That is 3. High is n minus 1 is 4. Res is negative 1. Low is less than high. Mid, low plus high. 4 plus 3, 7 divided by 2 is 3. Is suffix get mid at 3, that's a 2. is that less than array at 2, which is a 1? No, it isn't. So high is going to be mid plus 1. Mid plus 1. I'm sorry, mid minus 1. It's 2. All right, well, now we got a problem because low is no longer less than or equal to high. Okay, so we're going to set index I to res. Res is -1, and so this is -1. Okay, erase, 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 erase. I goes to 3, low equals I plus 1, high equals n minus 1. Okay, low greater than, less than or equal to high, yes. Mid equals low plus high, 4 plus 4, 8 divided by 2 is 4, is suffix get mid at 4, that's a 2. Is it less than array list at 3? Array list at 3 is 3. So yes, 2 is less than 3. So res equals mid. Mid is 4. All right, res is 4. Low is mid plus 1, 5. Okay, that is going to end the loop because low is now higher than high. Drop out of the loop and set index 3, 2, 4, right? It's right here. Good. Erase some of this stuff. And I goes to 4. Low is 4 plus 1 is 5. This is 4. That doesn't even go into the loop because low is already higher than high, and that's right because there's nothing to the right of that anyway. So we'll drop past the loop and we'll set index I, which is 4, to res, which is -1. All right, so that is our answer, and I think I can move this back. And so we can see that that does in fact match 2, 4, -1, 4, -1, 2, 4, -1, 4, -1. Okay, so that's how it works. Suffix array. Every element in the suffix array at each index, it contains the lowest number that occurs at or beyond that index, and that allows us to do well, it's going to be sorted, so it allows us to do a binary search and find the furthest element to the right. Again, we don't stop the binary search. That's a technique that we use sometimes on binary searches. We're not actually going to find an element and stop. We're going to find an element and keep going and see if we can find a better element, a further element, or a higher element, or a lower element. All right. Let's do this. Let's get rid of all the writing. Let's move this kind of out of the way. Let's move this over here. Let's do a sanity check on this. All right, that worked. Let's submit. Okay, that's it. Like the video, please. You can subscribe to the channel for free and get problems of the day emailed to you. And we'll see you next time.